This is the video for Lab 1 of Chem 223, Calibrating Volumetric Glassware. We'll be calibrating the glassware with regular water, but since regular water can be hard to see on video, we've dyed the water blue. We'll start with calibrating the burette. Notice that on the burette, the number starts at 0 and go up as you go down the burette stem. To fill the burette, put a funnel in the top and then pour your solution through there. Be sure to stop filling the burette before the solution reaches the funnel, otherwise you're likely to spill out of the sides of the burette. Once the burette is mostly full, remove the funnel. You can fill the burette the rest of the way using a plastic pipette. Turn the knob at the base of the burette to let liquid flow out. Turning the knob vertically will cause liquid to flow out quickly. You can control the rate at which the fluid comes out by turning the knob to an angle. Note now that the fluid is flowing out much more slowly. We're now ready to calibrate our burette. We'll start by weighing a beaker. Make sure to tare the balance first, otherwise you'll be measuring mass other than that corresponding to your beaker. We'll then take the beaker and place it under the burette and dispense 10 milliliters of water into it. Because we're trying to be as accurate as possible, this can be a long process. Note that I'm going fast at first, but as the solution starts getting close to 9 mils, I start putting my hand on the knob. I turn the flow of the water down low enough that the last mil almost takes as long as the first 9 mils to dispense. We'll then weigh the beaker a second time to determine the mass of water that was added. We'll then repeat this process, dispensing 10 mils at a time from the burette. And measure the mass after dispensing every 10 mils. We then determine the mass of water that was added by taking the difference in mass between every 10 ml aliquot. We'll now move on to calibrating the pipettes. These are loaded with a 3-way bulb. The bulb has 3 valves. The top is labeled A for air. This valve is squeezed to open it, and the bulb is squeezed to release the air to create a vacuum chamber. The second valve is labeled S for suction. This valve is squeezed to suck liquid into the pipette. The last valve is labeled E for evacuation. This valve is squeezed to evacuate fluid from the pipette. We're now ready to calibrate the 10 ml and 1 ml pipettes. We'll again start by weighing a beaker. We'll then fill the 10 ml pipette until the liquid reaches the line, indicating 10 mils. We'll then dispense the water into the beaker and measure its mass again to determine how much water was dispensed. Note that there is still some water left at the tip of the pipette. This water does not need to be evacuated for all 10 mils of the water to be delivered. The pipette is calibrated such that it will retain some amount of water. We'll calibrate the 1 ml pipette in the same way, by measuring the mass of a beaker by filling the 1 ml pipette with liquid. Sometimes it can be tricky to get the water exactly at the line. And then dispensing that liquid back into a beaker and weighing the mass of the beaker to determine exactly how much liquid has been added. Finally, we'll calibrate the 10 ml volumetric flask. In order to ensure that there's no water currently in the flask, we will put it in the oven for about an hour. After an hour, we'll remove the flask from the oven. Be sure to wear a glove or some sort of protective gear, as the flask will be hot. We'll weigh the volumetric flask. We will then fill the volumetric flask with water until the water reaches the line, indicating that the flask is full. Again, this can take a while if you're trying to be particularly accurate. Special effort is made to try and get the meniscus of the water as close to the 10 ml line as possible. We then weigh the flask to determine the mass of water that was added.